In this video, we're going to be looking at solving what I call non-vanilla trig equations. All right, these are ones which require just a little bit more work. Really important that you've watched the basic trig equations video first. So this is definitely sort of not vanilla. It's got both sine and cos in it. What we're going to do with these type is that we're going to make use of our identity that says that tan theta is the same as sine theta divided by cos theta. As long as the angles are the same, we can divide by cos theta to generate a tan theta. So here what we're going to do is we're going to divide both sides of the equation by cos theta, remembering that sine theta over cos theta is tan theta, so tan theta is -2. It's now what I would describe as a vanilla equation. We're looking for solutions in quadrants 2 and 4, with tan being negative. We find our key angle. Remember, the key to finding a key is that we don't put the negative into the calculator when we undo tan, and we get 63,4 degrees. Our second quadrant solution will be 180 minus, remember we always use the horizontal axis, so in fact theta will equal 116,6. 180 minus our key, 116,6 degrees. And because it's tan, we can just add 180k, k being an integer, and there's our solution, our general solution. Right, the next one's very similar. This time we've got sine 3 theta and cos 3 theta. We're going to divide both sides by cos 3 theta. And so we're actually going to get 5 over 2. I'm dividing both sides by 2 cos 3 theta. So I get 5 over 2 equals tan 3 theta. Now we need to get our reference angle, our key angle. We're going to get that by undoing tan of 5 over 2, which is 68,2 degrees. We're in quadrants 1 and 4 for tan to be positive, so 1 and 3 for tan to be positive. So here our general solution will be 3 theta, because that's our angle, is equal to 68,2. That's our first quadrant answer, the key angle, plus 180k. However, what we're then going to do is we're going to divide through by 3. So we're going to get theta is 68,2 divided by 3. I'm not going to bother to work that out. Plus 60k. Don't forget k element of z. And there is our general solution for that one. Right, now the next one is sine theta equals cos 3 theta. This is a problem because our angle is not the same in these two trig ratios. So dividing by cos 3 theta will not generate tan. Right, so we're going to show you how to do this. Basically, I'm going to work backwards from a fairly simple example to more complex examples. Suppose we had sine theta equals sine 20. Well, an obvious solution would be that theta is 20 degrees plus 360k. But another possibility, and I like to just think of our sort of all sine tan cos diagram here, another possibility is that theta could be 180 minus 20. In other words, 160 plus 360k. And that's kind of the general solution to this particular one, to sine theta equals sine 20, obviously with k as an element. So in this one, we've got sine theta equals cos 70. What we're going to do is we're going to leave this as sine theta, and we're going to change this to cos of 90 minus 20. Right, we haven't changed kind of anything yet. We've just written our 70 as 90 minus 20, but we know that the cos of 90 minus 20 is actually the same as the sine of 20. And now what we've done is we've reduced it to the same question as previously, with the same answers, obviously. So now let's take a look at this one. What we're going to do is we're going to leave this as sine theta, and we're going to change this to sine of 90 minus all of this stuff, 90 minus 20 plus theta. Okay, and so the one obvious answer is that theta actually equals 90 minus, I'm taking out the brackets, 90 minus 20 minus theta plus 360k. I'm going to leave some space to simplify that, but the other possibility is that theta is 180 minus 90 minus 20 minus theta plus 360k. So remember, the sine of 180 minus theta is the same as the sine of theta. Right. Now, in fact, in this particular one, what happens is we actually get theta is 180. This is 70. Is 180 minus 70. We actually get 110. Sorry, we get 70 plus theta plus 360k. What actually happens in this one is that we don't get any thetas if we subtract, so there's no solutions here. That doesn't always happen. Sometimes we will get solutions from both. In this one, we actually, if we add theta across, we get 2 theta equals 70 plus 360k. And so, in fact, the only solutions are theta is 70 divided by 2, 35 plus 180k. And that's with k an element of z. When I've solved one of these equations, I'm always tempted just to check a solution. So I'm going to, for example, I'm going to calculate a solution here with maybe k equals, let's say k equals minus 1. So it'll be 35 minus 180. So I'm suggesting that negative 145 is a solution. I'm now going to put that negative 145 right back into the original question and just check if the left-hand sides and the right-hand side are the same. Negative 145 rather. So I get negative 0.573 on the left-hand side. And if I find the cos of negative 145 plus 20, I get exactly the same. Right, that should give me a kind of warm, fuzzy feeling that I've got it correct. Let's now turn our attention to this one, which we initially encountered and couldn't do. We've got sine theta equals cos 3 theta. So let's leave this sine theta as sine theta, and let's change this to sine of 90 minus 3 theta. Right, when we've got this, either theta equals 90 minus 3 theta plus 360k, or theta will equal 180 minus 90 minus 3 theta plus 360k. This one will come to 4 theta is 90 plus 360k, or theta is 22.5 plus 90k. That's part of the solution. The other one is, this one's going to be 90 plus 3 theta, so we actually get negative 2 theta is 90 plus 360k. And here we would then get theta, if we divide through by negative 2, negative 45 minus 180k. Both of these with k, an element of the integers. And as we did previously, you could just go and check one of these answers. Let's just, for example, let's just check 22.5 degrees. If we find the sine of 22.5, we get that. And if we find the cos of 3 lots of 22.5, we get exactly the same. Right, let's take a look at these two. This first one is very different to the second one. The big difference between these two equations, this one has the same angle. Because it has the same angle, we can use our tan trick. So this one, we're going to divide both sides by cos theta. So we're going to get 2 tan 3 theta equals 3. So tan 3 theta equals 3 over 2. We're now going to appreciate that we need our answers in quadrants 1 and 3, with tan being positive. We're going to get our key angle. Our key angle is going to be found by undoing tan of 3 over 2. we get 56,3 degrees. So in fact, our solution is that 3 theta is 56,3 degrees plus 180k. 180k because it's tan, k an element of z. Don't forget that we still need to divide both sides by 3. So we're going to get 56,3 over 3 plus 60k. And that will be our general solution. The one on the right, completely different beast. We can't use our tan trick. We're going to have to either change this into sine or this into cos. Just to show you, I'm actually going to leave this one this time as cos of theta minus 10. And I'm going to change this one to cos of 90 minus 2 theta. Now when we've got cos equal to cos, the one possibility is that they are equal. In other words, that theta minus 10 is 90 minus 2 theta plus 360k. Right, I'm leaving some space to simplify that one. Or we could have that theta minus 10 is actually 360 minus this angle of 90 minus 2 theta plus 360k. Right, all the thinking's been done at that stage. The reason for 360 minus is that's the other place where cos has the same value. So cos of theta and cos of 360 minus theta are the same. Right, those are identities irrespective of the size of theta. But let's solve this for theta. We're going to add 2 theta to both sides. We get 3 theta. We can add 10 to both sides. We get 100. So in fact here theta will equal 100 over 3 plus 120k. Before I forget, I'm going to write k as an element of z somewhere on this page. This one here, we actually end up with theta minus 10 is 270 plus 2 theta plus 360k. I'm now going to add 10 and subtract theta from both sides. So I get subtract 2 theta from both sides. So I get minus theta is 280 plus 360k. And then I'm going to multiply through by a negative. So I'm actually going to get theta is minus 280 minus 360k. And again, it would be instructive and useful to just make up a value of k, a whole number value of k, and check one's solution. We're moving on to our sort of next and last type. And this one I'm hoping that you might pick is actually a trinomial. It's a sort of k substitution thing. Remember with a quadratic, we actually want a 0 on the right-hand side. So we've got 2 tan squared theta minus 7 tan theta plus 6 equals 0. This will actually factorize as follows. It factorizes to 2 tan theta and tan theta plus 3 and plus 2. In fact, minus 3 and minus 2. So we're going to get minus 3 tan theta minus 4 tan theta, and there we have it. So we're going to get, we've got 2 little vanilla equations to solve here. We get tan theta equals 3 over 2, right? Or tan theta equals 2. And we need to solve both of these. We're not after a general solution over here. Both of these have, we're looking for positive values for tan, in other words, quadrants 1 and 3. In this case, our key angle is 63,4. Right, and so in fact our solutions here are 63,4 degrees. Or the third quadrant, we're just looking for solutions between 0 and 360. 180 plus 63,4, 243,4 degrees. This one over here, we're going to need to find our key angle by going shift tan of 1.5. And we get 56,3 degrees. So the possibilities here are that theta equals 56,3 degrees or 180 plus 56,3 degrees, which is 236,3 degrees, or that, or that. So a total of 4 solutions for this trinomial. Right, this next one is a trinomial, but this time in sine. Pause the video, see if you can do it yourself, and then let it play. Right, this one factorizes to 3 sine theta and 2 sine theta. I think it's going to be plus 1 and minus 1. All right, so we get, that's correct. So we get sine theta equals a third, which we've got to solve. Or sine theta is minus a half. The solutions to sine theta is minus a half will be in quadrants 3 and 4, where sine is negative. Our key angle for a half, I'm not going to put the negative a half into the calculator. I'm going to undo sine of a half. It happens to be a special angle, it's 30 degrees. And we get 180 plus 30 is 210 degrees, or 360 minus 30, 330 degrees. The key angle for this one, this time though we're wanting positive solutions where sine, we're wanting solutions in quadrants 1 and 2 where sine is positive, and our key angle in this case is 19.5, I'm going to get 19.5 degrees. So in fact our answers here are theta is 19.5 degrees, that's in the first quadrant, or 180 minus that, which is 160.5 degrees, or 210 or 330. Right, now for our very last question, and this one sort of looks like a trinomial, but it's a little bit in disguise. Remember that sine squared theta plus cos squared theta is 1. That's an identity that you need to learn. And that means, in fact, that cos squared theta is the same as 1 minus sine squared theta. So what I'm going to do now is I'm going to substitute that cos squared theta value into this equation for the cos squared theta. And that will leave me a trinomial in sine squared theta. So I've got 1 minus sine squared theta plus 8 sine theta minus 7 equals 0. So we end up with negative 4 sine squared theta plus 8 sine theta minus 7 plus 4 is minus 3 equals 0. Let's divide everything through by a negative 1. So we're going to get 4 sine squared theta minus 8 sine theta plus 3 equals 0. This will factorize to 2 sine theta and 2 sine theta, a minus 1 and a minus 3. And so this time we get that sine theta is 2/3, sorry, 3 over 2, not 2/3, or sine theta is a half. Sine theta is a half is very easy, quadrants 1 and 2, right? And it's a key angle, it's 30 degrees. So the answers here are 30 degrees or 150 degrees. And in fact, over here, there are no answers. If you try and undo sine of 3 over 2, you get an error. Remember that sine ranges in terms of its outputs from -1 to 1. As always, if you found this useful, please subscribe, like, and share. Thank you.